Myself, Gautam VM, studying in Sri Venkateshwara College of Engineering, Bengaluru. Campax ID 23EC1656. First semester, Section 1, Applied Chemistry for Triple E stream. Subject code BCHE102. Today we'll discuss about corrosion. Corrosion and its controls. Definition of corrosion. Corrosion is defined as a destruction of metal or alloy by the surrounding environment through chemical or electrochemical reaction. The corrosion is divided into two types, dry corrosion and wet corrosion. Corrosion occurs in the absence of moisture. Corrosion occurs in the presence of conducting medium is called wet corrosion. In absence of moisture is called dry corrosion. Dry corrosion involves direct attack of chemicals on the metal surface. Wet corrosion involves formation of electrochemical cells. Dry corrosion is slow and wet corrosion is rapid process. Electrochemical theory of corrosion, taking iron as example. Iron is example for corrosion. At anode oxidation takes place in which the metal atoms are converted into their ions, liberating electrons. Fe gives Fe2 plus 2 electron minus. At anode, the cathodic reaction is based on the nature of the environment. In the absence of oxygen, liberation of hydrogen takes place. In acidic medium, liberation of hydrogen takes place. 2H plus 2 electron minus gives H2 ion. And in neutral and alkaline medium, hydroxide ions are formed with liberation of hydrogen. 2H2O plus 2 electron minus gives 2OH minus plus H2 ions. In presence of oxygen, in acidic medium, absorption of oxygen takes place. 4H plus O2 plus 4 electron minus gives 2H2O. In neutral or alkaline medium, hydroxide ions are formed. 2H2O plus O2 plus 4 electron gives 4OH minus ion. Then the iron ions Fe2 plus form anode combine with hydroxyl ions from to form a hydroxide on the surface between the anode and cathode area. Fe2 plus 2OH minus gives FeOH2 iron hydroxide. Then the iron hydroxide further reacts with oxygen and water forming hydrated iron oxide, which is the corrosion fault or rust. 4FeOH2 plus O2 plus 2H2O gives 2Fe2O3 3H2O rust particle. Types of corrosion: differential metal corrosion or galvanic corrosion, differential aeration corrosion. Differential metal corrosion occurs when two dissimilar metals are contact with each other and exposed to corrosive conducting medium. In the metal with lower electrode potential acts as an anode and oxidation gets corroded, and the other metal with higher electrode potential acts as a cathode, undergo reduction and protected from the corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. Example: bolt and nut made up of different metals. Differential aeration corrosion: when a metal is exposed to differential concentration of air or oxygen, part of a metal exposed to lower concentration of oxygen becomes anodic and undergo corrosion, whereas other part of a metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as a differential aeration corrosion. Example: iron rod is partially immersed in a NaCl solution. Part of a chemical immersed in a solution is exposed to lower concentration of oxygen, becomes anodic, undergo corrosion, whereas other part of a metal outside a NaCl solution is exposed to more oxygen, becomes a cathodic, remain unaffected. Types of differential aeration corrosion: waterline corrosion. The portion of tank below the waterline is exposed only to dissolve oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as an anode, undergo corrosion. This upper portion acts as a cathode, it is unaffected. Example: inside a water, the metals are rusted. Example C. Fitting corrosion. This type of corrosion is observed when the dust particle or oil drops deposited on the metal surface. Fitting corrosion results when the portion of metal covered by the dust, which is less aerated, becomes anode and undergo corrosion and form a fit. The remaining area of the metal which is exposed to higher concentration of oxygen becomes cathodic and remains unaffected. Corrosion control method. Methods of corrosion: cathodic protection, anodic protection, metallic coating. Anodic coating. The coating metal is anodic to base metal is called anodic coating. Example: galvanization. By galvanization process, anodic coating. Example: the sheet is coated by galvanization process. And cathodic metal coating. If the base metal is coated with a metal which is cathodic to it, such phenomenon is called as a cathodic coating. Example: the drum is coated with lead. Galvanization. Galvanization is a process of coating zinc on the base metal, Fe steel surface by hot dipping is known as galvanization. The galvanization is a process of carried out as follows. The metal surface is washed with an organic solvent. Solvents are CC14 toluene benzene to remove organic matter. The metal surface is treated with dilute H2SO4 to remove rust and other deposit. Then it is well washed with water and it is air dried by passing with hot air. The metal is treated with mixture of zinc chloride and ammonium chloride solution which prevents the oxidation of coated metal. Then the metal is dipped in molten zinc at 450 degrees Celsius. Excess of zinc on the surface is removed by the passing a pair of hot roller, which removes the excess of zinc and produces thin coating. Example: iron sheet is dipped in a organic solvent to remove organic matter, and then it is dipped in a dilute H2SO4 to remove the rust. Then it is washed with water and air dried, and metal is treated with mixture of zinc chloride and ammonium chloride to prevent oxidation of the coated metal. This metal is dipped with molten zinc at 450 degrees Celsius. The excess of zinc present in the surface of metal is removed by passing a hot rollers, which removes the excess of zinc and produce a thin coating of metal. Then examples are roofing sheets, painting, pipes, doors, mold, mesh, etc. Thank you for watching.